All right, we are starting gas stoichiometry. And we're going to start this discussion working volume to volume problems. Before we go over volume to volume problems, we need to talk about Avogadro's principle. And what his principle says is that if the volumes are equal, and they have equal temperature and pressure, then the gases, and this is only for gases, that gases will have equal number of particles for that particular volume. And the reason why this is true is because, remember when we were talking about kinetic molecular theory for gases, that the molecules, or atoms, but they're usually molecules for gases, but the molecules are far apart compared to their size. And so what this means is that the difference in the molecule size is negligible. And so we can now assume that all molecules of a gas have the same, quote, size. And the best way to do this is just to jump right in and do a problem. Okay, next. Okay, so what we're going to do is, since they have, because of Avogadro's principle, since we can say that the molecules have the same size and that their volumes are equal for equal pressures and temperatures, then we can say that the coefficients for, so let's go to stoichiometry. So what this implies for stoichiometry is that the coefficients, C-O-E-F-F, let me spell this correctly. The coefficients are not just mole ratios, but they can be volume ratios if the reaction is exclusively in the gaseous phase. So what we're going to do is we are going to do an example together. Okay, so what we have here is a problem that we are combusting propane. So let's start with our chemical equation. So what we have is, we have C3H8. It's a combustion reaction, so he's reacting with oxygen to give carbon dioxide and water. And we need to balance this equation. So we have a 3 here, we have a 4 here. That gives us 6 oxygens, or 6 oxygens, oops. And this guy, there's 6 and 4, oh, that is 10, which means that this coefficient needs to be a 5. Okay, and so what we're given is we have 4 liters of propane, and we are looking for the volume of oxygen gas, assuming that temperature and pressure remain constant. So rather than go through and figure out the number of moles that we have, we can just use our coefficients to find a volume ratio. So according to our chemical equation, we have 1 liter of propane. Oops, propane is H8. So we have C3H8, and we're trying to figure out volume of oxygen gas, so that will give us 5 liters of O2 because our coefficient for oxygen is 5, and that is going to give us an answer of 20 liters of O2.